All right. Hello, section 4.3. We're going to be writing equations of parallel and perpendicular lines. Okay, so first, a little bit of vocabulary. What are parallel lines again? Parallel lines have to be in the same plane, meaning you can draw them on the same piece of paper. In the same plane, never intersect. Okay, so they're in the same plane and they never intersect. Then they would be parallel lines. Railroad tracks are considered parallel lines. Okay. One thing interesting about parallel lines is they have the same steepness. Parallel lines have the same steepness. So however steep one line is, all the lines parallel to it are just as steep. So since they have the same steepness and slope is a measurement of steepness, then parallel lines have the same slope. So to determine whether two lines are exactly parallel, if you find their slope and their slopes are the same, then you know they're parallel. So here, we're given three lines. We've got the blue line, line A, the red line, line B, and then the green line, line C. It says determine which of the lines are parallel. So to determine parallelness, I'm going to find the slope. So here for line A, and so in my notes, I'm going to write down, okay, so for line A, we're going to look at the slope. The slope is, and I'm just going to count. So down 1 over 1, 2, 3, 4, 5, over 5. So rise over run, so that would be negative 1 over 5 for line A. So now for line B. The slope for line B is, we're going to do the same thing. This one looks like it's down 1, and then over 1, 2, 3, 4, over 4. So the slope of that one is down 1 over 4. So negative 1 over 4. So I can tell those two are not parallel. They do not have the same slopes. We have one more line, line C. This one, down 1, over 1, 2, 3, 4, 5, over 5. So the slope for line C is down 1 over 5. So since A and C have the same slopes, we would write A is parallel to C. So this symbol right here means parallel. They're two long up and down lines that extend higher than just a normal one would be. So that means parallel. So determine which of the lines are parallel, A and C, because they have the same slopes. Okay. So if I want to write the equation of a parallel line, so here it says write an equation of a line that passes through, we want it to go through this point, and we want it to be parallel to this. Okay. I'm going to sketch a visual of this. So I want to sketch this. So I'm going to come in and I'm going to get my XY axis in here. And I'm going to sketch this line right here. This line has a y-intercept of 3. So it crosses the y-axis up here at 3. And a slope of 2. So that'd be 2 over 1. So rise of 2, run of 1. So this line's going to look like this guy right here. So I want to be parallel to this red line, but I want to go through this point here, the point 5, negative 4. So where is that point? 5, 1, 2, 3, 4, 5, down 1, 2. Okay, so I want to go through this point and be parallel. So we can kind of visualize what it's going to look like. It's going to kind of look like this, but we want the equation for it. Well, I know a point it goes through, so really I've got an x1, y1 from our last video. And I know what slope it has to have. Look at this red line. What is the slope of this red line? The slope is 2. And we know from up here, parallel lines have the same slope. So my parallel line going through that blue point has to have a slope of 2. So I'm going to use y minus y1. And I'm going to use the point I want it to go through. I want it to go through point 5, negative 4. So y minus a negative 4 is going to turn that plus 4. I want it to have a slope of 2, the same as this line over here. Oh, slope of 2. And then x minus x1 is 5. So now I can simplify this. Let's distribute 2x minus 10, subtract the 4, 2x minus 14. So there is the equation of my parallel line. Okay, so now stop. I want you to pause the video and go and do these problems. Page 191, 4 through 12 even. Okay, so stop, go and do those problems. Okay. All right, welcome back. If you have not gone and done these problems yet, please go do them. That is the order in which this lesson is meant to be done. Okay, because now we are no longer talking about parallel lines. Right now we're going to be talking about perpendicular. Perpendicular lines are lines that intersect to make a right angle. If you remember from middle school geometry, a right angle is a 90-degree angle. Okay, it's a 90-degree angle. Okay, well, they aren't, it's not as easy as our parallel where they have the same slope. If you want perpendicular lines, their slopes, first of all, if I have a line going up and I'm perpendicular, that line's going to be going down. So it needs to have an opposite sign. Meaning if one's positive, the other's negative. So opposite sign, if one's positive, the other one's going to be negative. And the steepness is reversed. So this one here is less steep and this one is steeper. So they have opposite sign and they are what we call reciprocals. Reciprocals, for example, 1/2 and 2/1 are reciprocals. 2/3 and 3/2 are reciprocals. Don't put them equal to each other. They're not equal. They're what we call reciprocals. So to denote the opposite sign, a lot of times we just say negative, because to make something a different sign, if I have 5 and I want to make it the opposite sign, I put a negative in front of it. If I have a -4 and I want to make it the opposite sign, I put a negative in front of it. It's the negative of -4, which ends up being +4. So we want negative reciprocals. So perpendicular lines have negative reciprocal slopes. Okay. So for me to tell if any lines are parallel or perpendicular, I need to find their slopes. Sometimes it's pretty straightforward finding the slope. Here in this example 3, this line A, y equals 4x plus 2, I can tell there the slope is 4. Okay. Hey, this next one though requires a little work. I'm going to have to subtract the x from both sides. So I have -x plus 3 and then divide by 4. So I'd have -1/4 x plus 3/4. So here my slope is -1/4. So if you notice, this slope's positive and it's 4, or 4/1. This one is -1/4. So line A and B are perpendicular. Because that's not how you spell perpendicular. Because they have negative reciprocal slopes. Okay, and last one, let's do this last one, line C. Let's compare this guy. I know to add 2x to both sides. -8y equals 2x plus the 16 divided by -8. Y equals, the 2 divided by -8 is -1/4 x minus 2. Well, this one has the same slope as this. So I know B and C are parallel, which then means that A and B are perpendicular and line A and C are also perpendicular. Okay. All right, this next example, we want to write an equation of a line that passes through. This is very similar to this example 2 that we did over here, except we want to be perpendicular, not parallel. So I'm going to start it out in much the same way. I'm going to start by graphing this line. I want to see what that line looks like by sketching it out. Red. This one has a y-intercept of 3. These across the y-axis up at 1, 2, 3. And a slope of 1/2. Rise of 1, run of 2. And now I want to go through the point -3, 1, -3, 1, and be perpendicular. So I no longer want to be parallel, I want to be perpendicular. I want to make like a 50-degree. Okay, so something kind of like that. So I know what point I want it to go through. So I've got my x1, my y1. But unlike the last one, I want it to be perpendicular, which means I need a negative reciprocal slope. So instead of using a slope of 1/2, I'm going to use a slope of -2/1. But other than that, it's the same process. Y minus y1. I use my x1, y1, x minus that 1 right there, slope of -2, x minus a -3, which means +3. And now simplify. -2x minus 6, add the 1 to both sides. Y equals -2x minus 5. Now we can sketch this guy and make sure he is in fact perpendicular. So it needs to have a y-intercept of -5 and a slope of -2, down 2/1. So it's going to look like that. Well, look at there. It made a 90 degrees, and it even went through the point we wanted it to go through. Okay. All right, very last example. Okay. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is the one that is perpendicular. We want to make a 90-degree. Write an equation that represents this path. So we want to write an equation for this red path. We have a point for it to go through, the point 14,4, and we have a graph, so I can count the slope. So let's go ahead and let's count the slope here. Okay, for this red one, it goes down 1, 2. Well, we better find another point we want to use. This point looks like a good one right here. So we'll go down 1, 2, 3, down 3, and back 2. So my slope is down 3, back 2. 2 negatives make a positive 3/2. So I'm going to use a slope of 3/2 and a point of my x1, y1 is 14,4. Oh, sorry, it won't let me unzoom. Okay. Y minus y1. Okay. My y1, let's look over there, is 4. Slope is 3/2. My x1 is 14. Okay. So y minus 4 equals, I don't know what 14 times 3 is, so we have 3/2 x. 42 over 2. 42 over 2 is 21. Equals y minus 4. Add the 4 to both sides. Negative 21, add 4, 17. Okay, so there's the equation of my flight path. Okay, now the last bit of practice, you've already done some from over here. Now I want you to go ahead and add to that. I want you to do page 191, number 2, so go back and do number 2, and then 14 through 28 the evens, 28 and 37 through 38.